Hello everyone, welcome to MAPS. My name is Diane Munzenmeyer. If you don't know me, I know some of you are here for the first time doing the MAPS program. Some of you are coming back for your second or third year, but welcome to all. This year, as you probably know, we are going to be modeling an insulin story. So I wanted to give you a little bit of an overview of what insulin is, what insulin does. We're going to be learning about it throughout the school year, so I'm not going to give you a lot right now, but just enough so that we're all starting from the same place and we can kind of build from that place as we go. But as a lot of you have said, insulin is important in glucose metabolism or glucose homeostasis. And homeostasis is just a big word for trying to maintain a balance, or maintain a steady state. Glucose, as you probably know, is really important to our bodies. All of our cells utilize glucose to produce energy to fuel all of our cells. And there's no organ that's more dependent upon glucose than the brain. In fact, at rest, 60% of the glucose in our blood is utilized by the brain. So it really needs immediate access to glucose at all times. So it's really important that our blood has a reasonable level of glucose at all times. However, glucose can also be toxic to certain cells, and especially endothelial cells, neurons. So our blood vessels and our neurons are very sensitive to high levels of glucose. So when we eat a meal and we have a lot of carbohydrates that are broken down into glucose, our blood sugar goes way up. Our blood glucose levels go way up. And if it would stay at that level, it would cause lots of trouble. It would be toxic to our blood vessels and our neurons and everything else. And that can be a really big problem in diabetes. So it's important that insulin is released by the pancreas when that happens. So the pancreas beta cells, the islets of Langerhans, the beta cells in the pancreas sense the glucose in the blood, the high levels of glucose in the blood, releases insulin. And as we will find out later in the program, insulin acts in a variety of ways to bring glucose down, primarily by storing glucose for later use. Okay, so it builds up big stores so that we can keep our levels and release it slowly over time, so we don't have these huge spikes. When that doesn't work, we have something called diabetes mellitus. And there are a couple of different kinds. So there are different kinds of diabetes too. We usually just call it diabetes, but there's something called diabetes insipidus and some other things. Diabetes mellitus is what we're talking about with insulin. And type 1 is what used to be called juvenile onset. It's when your body cannot make either enough insulin or at least enough working insulin. And so there are different ways why that might happen, and we're going to explore those later on. Then there's another form called type 2. Sometimes it used to be called adult onset diabetes because it used to happen to people after they got older, but now it's happening to kids in high school and in middle school even. And it's partly because of how our lifestyles have changed. We're eating worse foods. We're eating junk food. We're eating high fats, high sugars. We're not getting enough exercise. Tobacco use is a problem. So all these things are risk factors for diabetes type 2. So this is a huge problem in the U.S. and in the world. Right now, almost 10% of the world population has a form of diabetes, and 90% of that is type 2. So if there's anything that you get out of this project that you work on this year, is hopefully you have a greater respect for how our bodies keep things going and keep things constant, our glucose levels constant, and try to do everything you can to live a healthy lifestyle to keep that going. So one other thing that I would really like for you guys to take a look at before you move ahead with the modeling projects that we're going to do is take some time to look at the historical page that I have of the research that's been done over the past 150 years. I mean, I can't think of another area that has been so active in scientific research over that span from the 19th century to the 21st century. It's really pretty impressive. It goes all the way back to 1867 when Paul Langerhans actually looked at a pancreas and pancreas cells and noticed these really interesting looking cells that kind of look like islands. And he called them the islets of Langerhans, and those happen to be the beta cells that secrete insulin. So that was the very first finding that really started this whole process of understanding insulin and its role in diabetes and glucose homeostasis. So take a look at that list. It's really pretty impressive at how each finding kind of built on what happened previous to that, and it's just been progressing for all this time. And even today, it's still a very active area of research. Three really important parts of that timeline are the fact that there were 3 Nobel Prizes that were conferred for insulin research. The first one was the identification of the fact that that the pancreas secreted insulin, and that was what the factor that was needed to save these people who were dying of diabetes. If you want to take a look at this book, it's a really fascinating book of describing how that all happened. And this Banting here and Best, who were told that they didn't know what they were doing when they were really trying to figure this problem out, ended up really saving lots and lots of lives by coming up with the identification of insulin. That was in 1921. In 1955, Fred Sanger then finally was able to sequence insulin, and it was the first protein that was ever sequenced. He won the Nobel Prize in 1958 for that. And then in 1969, this woman over here, Dorothy Hodgkin, actually identified the structure of insulin. And she was able to do that because she took the sequence that was previously identified and then used X-ray crystallography to identify the structure. And at that time, it was really early in X-ray crystallography, and people weren't thinking that you could determine a structure that was this complicated. And she not only did this, she identified penicillin and vitamin B12, and she received the Nobel Prize for those as well. Today, there's still all kinds of research going on. So now we know what insulin does and how it does it. But now, there's so many people. Like I said, 10% of the world population have diabetes. And so there's a lot that needs to be understood about how this happens and how we can better treat these people. And so a really hot area that's happening now is trying to make a better insulin. And this might be something that you would like to model for your project. There's all kinds of protein engineering that's going on with insulin, changing amino acids, tweaking the structure to either make it more accessible to the cells or to make it more able to be stored for longer, slower release type of things. So there's lots of different types of tweaks that are being done and trying to figure out what the best way of doing this is. So there's lots of stories for you guys to look at and think about modeling. So as you go through this program, keep talking about that and figure out what you want your protein story to be. All right, so I will be talking to you on the discussion boards, and I'll check in with you again later. But until then, learn as much as you can about insulin, and we'll see you in a little bit.